Welcome to my channel. In the subject design and analysis of algorithm, let's see Quicksort today. Quicksort uses the divide and conquer methodology. Here, the problem size is divided into half. For example, the problem of size n can be divided into two n by 2 subproblems, and here we are finding the solution for the subproblem separately, and finally we are getting the solution for the original problem. And here the Quicksort divide the input elements according to their value. So here we are using the partition. The partition element is known as pivot element. For example, in an array of size from A0 to n minus 1, if you are taking A of s is the partition element, all the elements of left hand side to this partition element is less than A of s, and all the elements which is present in the right hand side of A of s is greater than A of s. This is the Quicksort algorithm. Here the input is a subarray A of L to R of A of 0 to n minus 1. So here this L and R is used to denote the left and rightmost indices. And the output of this algorithm is the sorted array. Here we have to check this condition whether this L is less than or every time, because this is a recursive function. Each and every time we are calling this function again with the subarray. So sometimes we have to stop from there, so that we need to use this condition L less than or. Then here we have to call the partition algorithm. I'll show it in the next slide. And the output of this algorithm is the pivot element. That is, we are passing the subarray of L to R to the partition algorithm. It will perform the operation on this array and find the position of the pivot element. That is, the split position is written here, and it will be stored in this variable S. Now we are calling the algorithm recursively 2 times by passing the array of size A of L to S minus 1. That is, we are taking the leftmost index from to this left to this split position. Likewise, again we have to call the Quicksort algorithm with A of S plus 1 to R. That is, the next element of the pivot element to the rightmost indices. So here the original array A of 0 to n minus 1 is divided into half based on the split position. One is from L to S minus 1 and another one is from S plus 1 to R. So this process will be repeated recursively until all the elements are sorted in non-decreasing order. This is a partition algorithm. Here we are providing an subarray as the input A of L to R. And the output of this algorithm is the split position, that is the pivot value. So that initially we are assigning the first element as the pivot element. So that I am assigning A of L to P here. Then two iteration variables used, I and J, and I is assigned with the L, that is the first leftmost indices, and the J is assigned with R plus 1. Then we are using the do while loop, and this loop will be repeated until I is less than J. That is, if I is greater than or equal to J, this process will be stopped. Likewise, within that loop, there are two more do while loops are there for incrementing and decrementing this I and J value. So let us see how this algorithm is working. So consider this is an array. So the first element is taken as the pivot element. Now we are coming inside the loop. We have to increment the I value, then we have to check the condition. So each and every time I is incremented, then it will check whether the element is less than this P. That is, if suppose the element is greater than the pivot element, the incrementation will be stopped. Likewise, we have to decrement the value of J, and we are checking whether this element is greater than this P. So if it is greater, again the loop will be executed, otherwise it will stop. So these two loops are do while loops. So first the incrementation operation is performed, then the condition will be checked. And at a particular time, the control is coming out of this two do while loops. So now we have to swap the element which is present in A of I as well as A of J. So that's the condition here. So if you are incrementing the value I, and suppose this I is stopped here, likewise you are decrementing the value of J and J is stopped here. So now you can interchange these two values I and j. So that's the process. And after completing this interchanging operation, we have to check this condition. So if I is less than j means we can repeat the process. Otherwise, we have to coming out of this loop. That is, when this I is crossed over this j, we have to stop this process. So if suppose I crossed here, I is greater than this j value means I and j is crossover. So in that time we can come out of the loop and we have to undo the last swapping. That is, again you have to interchange the value of I and j once again. Then you have to swap the element a of L with a of j. The meaning is you have to interchange the pivot element with the element which is present in the jth location. So now the pivot element is interchanged here and now it is in position. So the thing is, this is the pivot elements location. Now all the elements which is present in the left hand side of pivot is less than this p, as well as all the elements present in the right hand side of p is greater than p. So now this algorithm return the jth location, that is the jth index, that means the index of the pivot element. Let us see one example. Here the array size is 8. Now we are calling the quicksort algorithm by passing this array. So L is 0 and R is 7. So now if L is less than R means we have to call the partition algorithm. So in this partition algorithm we are passing this array. Now we are assigning the A of L value to P here. So A of L, that is 0, A of 0 to this partition element, so that 5 is stored in P. Now we have to assign L to I and R plus 1 to j. So I will be present here and j will be present in this location. Now we have to call the do while loop, and here we have to increment the I value. Then we have to check the condition. So we are incrementing the I value and we are checking. So now 3 is less than 5, so that again we can increment the I value. So this loop will be repeated until this A of I is greater than or equal to the pivot element. Otherwise this loop will be repeated. So here 3 is less than 5, so that we can repeat the process. Now I becomes here 1 is less than 5, so again we can increment the I value. Now 9 is greater than 5, so that we can stop the do while loop. We can stop this first do while loop. Then the next do while loop we have to decrement the j value. So j will be decrement from here R plus 1 location to rth location. Now we have to check here the element 7 is greater than 5, so that we can decrement j value again. Here the condition is j should be decremented until A of j is less than or equal to p. If you are reaching any value which is less than the pivot element, we can stop this loop. So that here the 7 is greater than 5, again we are decrementing the value j. So now 4 is less than 5, so we can stop the process. Now we are coming out of these two loops, so we have to interchange the element which is present in A of I and A of j. So here A of I element is 9, A of j is 4, so we have to interchange 4 and 9. So after completing this process, again now we have to check the condition whether this I is less than j. If I is greater than j means we have to coming out of this loop. So now I less than j condition satisfied, so that we can repeat the process. So now again we have to increment I here and compare the element. Now 8 is greater than 5, so that we have to stop incrementation. Likewise we have to decrement j here. 2 is less than 5, so we can stop the process. So we are now coming out of these two loops. Now we have to interchange the elements A of I and A of j. So now these two elements is interchanged here. 2 and 8 is interchanged. Okay. Now again we have to repeat the process. I is less than j, so that we can increment I here. Then we are comparing the condition. Now 8 is greater than 5, so that we can stop the process. Likewise j should be decremented. Now 2 is less than 5, we can stop the process. And now I is greater than or equal to j. That is I crossed over j. So now we reach this condition. So we have to coming out of this do while loop. Then we have to do the undo the last swap. That is again you have to interchange 2 and 8 here. Then you have to swap the element which is present in A of L to A of j. So now the A of A of L is 5 and A of Jth element is 2. So we can interchange 2 and 5 here. So now 5 will be present in this location. That is the fourth index value. So now this algorithm written J value. So now it will be stored in here, this S position. So the meaning is now this array in this look like this, and here the pivot element is present in its own position. So now all the elements left to this pivot is less than 5, and all the elements which is present in the right hand side to this 5 is greater than 5. Now again we have to call this quicksort algorithm with the two partition. One is from A of L to S minus 1, that is from 0 to 3. The index from 0 to 3 we have to call this subarray. After, again we have to call this partition. The same process will be repeated and we have to arrange all these elements. Likewise, again we have to call the quicksort algorithm with A of S plus 1 to R. S plus 1 means 5. From index 5 to 7 we have to do this process again. So the right subarray will be sorted. So this process is repeated. Finally, we can get the sorted array. This slide shows about the analysis of quicksort algorithm, and here this is for best case. And if the number of key comparison here is n plus 1 if the scanning indices crossover, that is I and j values crossover, means the number of comparison required is n plus 1. And if they are coincide, that is j and I is present in the same location, means we need n number of comparison. And here this best case denoted that all the splits are happen in the middle of the subarray. So every time if you are getting the pivot element in the middle location, we can consider this is the best case, so that the recurrence can be written like this. So C best of n is equal to 2C best of n by 2. The thing is, here we are dividing the algorithm, that is the number, into two halves, and we are calling the quicksort algorithm recursively. So 2 times we are calling the quicksort algorithm recursively, so that 2C best of n by 2. Then we are calling the partition algorithm, so that we are using n here. So after applying this mathematical analysis of recursive algorithm general plan, we can get the solution like this: n log to the base n. The worst case of the algorithm is if all the splits are happened at the extreme end. If suppose if you are considering an array like this, always the pivot element is present in the first element, or sometimes the pivot element will be present in the last location. So in that time the array will be split into two halves, that is only one element in the subarray and all the remaining elements are present in the right subarray. So in that time the total recursive tree will be skewed to the extreme end, that is one side, on the right hand side or sometimes the left hand side. So in this type of input value, we have to calculate the worst case analysis. This slide shows about the recursive tree for this split up, and here the n elements are divided here. So the first element will be present here and the remaining n minus 1 element will be present in the right subtree. Likewise, while you are performing the next iteration, means the second element is considered as a pivot element. All the remaining n minus 2 elements will be present in the right subarray. This has happened like this, so that this split operation is skewed to this right extreme. So we can calculate the running time of this algorithm by C of n is equal to C of n minus 1 plus n. Each and every time we are skewed to the extreme. So this is the worst case input. So while you are solving this mathematical analysis, we can get the value like this, n into n plus 1 by 2, so that we can tell the worst case running time of this algorithm is n square. And this slide shows about the average case analysis. So if the partition is happen anywhere of this array, that is other than the first middle and the last element, if the partition happened in somewhere, we can take the probability value. So it is equal for all the position, so that if you are considering there are n plus 1 comparisons are there, so after the partition the left subarray having s elements and the right subarray having n minus 1 minus s element. So that we can get the average time analysis here. We are taking the probability value, so that 1 by n sigma s is equal to 0 to n minus 1. We have to consider from s from 0 to n minus 1 and take the first n plus 1 comparison, then average of this s value, then the average value of n minus 1 minus s. So then finally we can get the value like this, log to the base n. So the quicksort algorithm, the best case and average case analysis is n into log n, and for the worst case we can we need n square time for completing the quicksort algorithm. Hope you got idea about quicksort. Thank you for watching.